Now please turn to page 13 of chapter 35. Let's talk about calculating standard enthalpy change of reaction using standard enthalpy changes of combustion. First of all, please highlight using standard enthalpy change of combustion. In other words, in the question, all the combustion data are given. Under this situation, we have another equation. This is the equation that you need to learn. If the combustions of reactants and products are given, then you can calculate the enthalpy change of a reaction according to this equation, which is the summation of the heat of combustion of reactants minus the summations of heat of combustions of products. Okay, now it's different from the one that you have learned. If the data all are formation, then we need to calculate summations of heat of formations of products minus summation of heat of formations of reactants. Totally different, okay? Now I will explain to you why the equation is totally different if the combustion data are given. In order to explain, we need to refer to this example. Turn to page 13. Let's look at this example. Here we have a reaction. H2 react to sulfur to form H2S. And then their combustion data are given. First of all, can you tell me what is the definitions of combustion? For example, what is the meaning of standard enthalpy change of combustion of H2S? Do you remember what is its definition? Is the enthalpy change when 1 mole of H2S is burned completely in oxygen under standard conditions. Do you remember? This is the definition, okay? Now, in other words, here is your target reaction. I will put it down horizontally. And now, the combustion of H2S is given. It is the enthalpy change when 1 mole of H2S, that means H2S is the reactant, react with oxygen completely to form H2O and SO2 under standard conditions, okay? SO2 is a gas, H2O is a liquid. Balance this equation. How many O? We need 3/2. We need 3/2 O2. You understand? I label it as delta HA. I need to calculate delta H. Delta HA is equal to the standard enthalpy change of combustion of H2S. Do you understand? Now, I will complete the cycle in this way, drawing an arrow. I label it as B, delta HB. What is delta HB? Okay, it is the combustion of H2, 1 mole of H2. That means combustion of H2 plus S. We need to balance the equation. We need to put 3/2 O2 on the equation. Combustion of sulfur. Using Hess law again, take out 2 color highlight pen. Can you find out which 2 are in the same root? Delta H and delta HA belong to the same root. And delta HB HB belong to another root. Cauterize, cauterize, anti-cauterize. So according to Hett's law, delta H plus delta HA is equal to delta HB. In other words, delta H is equal to delta HB minus delta HA. What is delta HB? It is the summation of the heat of combustion of these reactants minus summation of heat of combustion of products. Bear in mind this equation, okay? Now, let's try example 35.4.